All right, Charles' law. Okay, Charles said that at constant pressure and moles of gas, this is what he observed. So start at 25 degrees Celsius or 298 Kelvin. So the gas has that volume. Increase the temperature, the volume also increases. Decrease the temperature, right now go down to 0 degrees Celsius, the volume of gas dropped as well, so decrease as well. Okay, so basically, if you increase temperature, the volume increases. So he concludes this observation as volume is directly proportional to temperature. If you make it as an equation, V equal constant K times T, or V over T is constant. Okay. And the application of Charles' law, the situation 1, V1 equal to T1, the situation 2, V2 over T2, they are equal. These two are equal. That allows you to be able to calculate for either volume or temperature in two different situations. All right. Let's check it out right here. What temperature in Celsius? So watch out then. In the equation, you have to do Kelvin, but the question asks for Celsius. You have to convert between Celsius and Kelvin. What temperature in Celsius is required to increase the volume of a sealed balloon from 2 liter to 3 liter? All right. Initial temperature is 15 degrees Celsius. So that's situation 1, 2 liter, 15 degrees Celsius. The situation 2 is 3 liter. Now, what's the temperature? All right. And so always, we are about to use the equation. So we have to convert degrees Celsius to Kelvin. So at plus 273, you get to Kelvin. All right. All right. So if you look at the combined gas law, so mole still the same, pressure still the same. So cancel out. Basically, we down to Charles' law. Yeah. We want to solve for T2. So I'm going to put T2 to the left side. Put V1, T1 to the right side. So T1 goes to the top, V1 goes to the bottom. So rearrange the equation. All right. Now plug in. So V2 is 3 liter. T1 288 Kelvin. Put down there. And V1 is 2 liter. All right. Do the math there. Liter cancel out. You get to 432 Kelvin. But hold on. The question asks for Celsius. So we have to subtract 273 Celsius to 159 Celsius. Okay. All right. So that's just the thinking. Okay. So Charles think that, well, if we increase the temperature, so to the right, the volume of the gas also increases. If we decrease the temperature, the volume goes down. What if we just keep decreasing the temperature? Will we get to the point that the volume of the gas go to 0? Is that possible? So mathematically, it's possible. So by math, right? So they extrapolate. Well, we can't really go down lower than 220. We don't really have anything that is that cold, right? But we extrapolate the graph. As we decrease the temperature, volume comes down. Volume comes down. So volume on the y-axis, and that we extrapolate to. It's interesting that all the gas, so we have 4 type of gas here, right? 5 gases, and all of them, when we decrease the temperature down to absolute 0 or negative 273 degrees Celsius or 0 Kelvin, all these gases have 0 volume. That's very interesting, right? In theory, it's possible. So he's in theory. So at high temperature, the gas molecules, they move quickly. So they hit on the side of the container, so they have some volume. At low temperature, the gas molecule moves more slowly. At the lowest temperature possible, what happened to the speed of the gas molecule? We'll expect that or the gas molecule will have no speed at all, no kinetic energy, right? If the gas molecule have no speed, so which means they don't move, what happened to the volume? Well, go to 0 volume. There's no volume, right? But that's in theory. We can't really go any lower than. We can, but it's very difficult. If you use dry ice, that's a negative 79 degrees Celsius. Use liquid nitrogen, that's negative 196 degrees Celsius. It's so difficult to get to negative 273 degrees Celsius. Okay, so we never get to that point. But in theory, the volume of the balloon should be 0. All right. I got a video for you. This show Charles' law.
When an air-filled balloon at 273 degrees Kelvin is placed into liquid nitrogen at 77 degrees Kelvin, the balloon decreases 1/273rd in volume for each degree drop in temperature. Charles's law states that the volume of a quantity of gas at constant pressure varies directly with the Kelvin temperature. As the balloon warms back up to 273 degrees Kelvin, the balloon returns to its original volume.